Hi guys, this is a video on finding and factoring out a GCF using factor trees. So looking at this example, my three coefficients are rather large numbers, and without the use of a calculator, it's not so easy to tell what the greatest common factor is. So using a factor tree or prime factorization of these numbers is a strategy that I have to find my greatest common factor. So I'm going to build a factor tree for each of my three coefficients, starting with 135. So I'm just trying to come up with two factors that multiply to give me 135, and ultimately I want to end up with all prime numbers. So 135 is divisible by 5. I'm going to come down here and do some quick long division. 5 goes into 13 twice. 2 times 5 is 10. Subtract. Bring down my 5. 5 goes into 35 7 times. 5 is prime. 3 times 9 is 27. 3 is prime. 3 times 3 is 9. And now I have all prime numbers. I'll do the same thing for 315, which is also divisible by 5. 5 goes into 31 6 times. Subtract, bring down the 5. I have 63. 63 is divisible by 3. 3 goes into 6 2 times. 3 goes into 3 1 time. 3 is prime. And 3 times 7 is 21. Both are prime. And finally, 240. This is even, so I'm going to start by factoring out a 2, which is prime. Still even. Still even. Five times 3 is 15. Alright, so I've got my prime factorization for each of these numbers. And what that means is that 5 times 3 times 3 times 3 is going to give me 135. So I'm looking for the factors that they have in common. They all have a 5 in common, here, here, and here. And they all have a 3 in common. Beyond that, there aren't any other factors that are common to all three numbers. So 5 times 3 is going to be 15, which is my greatest common factor of the three coefficients. Taking a look at my variables, a cubed, a squared, and a to the fourth, my greatest common factor is a squared. And for b, b squared, and b to the cubed, my greatest common factor will be b. Okay, so now to actually divide out my greatest common factor. So now that I know that 15 goes into 135, I have to know how many times. I can still use my factor trees to help me to figure this out. I've already used the 5 times the 3 to get the 15, so my other remaining prime factors are 3 and 3. So if I multiply those together, I get 9. So 15 times 9 is 135. A cubed divided by a squared is a, and b divided by b is just 1. Plus, so 315 divided by 15, same thing. I already used the 5 and the 3 to get the 15, so 3 times 7 is 21. A squared divided by a squared is 1, b squared divided by b is b, minus 240 divided by 15. So 15 times 3 was already used. Looking at my other prime factors, 2 times 2 is 4, times 2 is 8, times 2 is 16. A to the fourth divided by a squared is a squared. And b cubed divided by b is b squared.